Publishing Part 1, a publishing overview and web publishing. I was originally going to call this nugget Configuring Access to Internal Resources, but once I started laying out the flow and what I was going to talk about, I thought, man, ISOServer does allow you to do a whole lot with this part of the configuration, so I decided to break it into two pieces. And in this first nugget on publishing, we're going to talk about what publishing is. You already know the basic definition. It's configuring access to internal resources, but we'll get more in depth as to what this means to the ISA server. The next thing that we'll do in this nugget is talk about configuring web publishing. And by the time we're done here, you'll be able to configure your ISA server to allow outside access to your internal web servers. Webster's Dictionary defines publishing as to prepare and issue for public sale or distribution. And that's exactly what happens when you use the ISA server to publish some of your internal servers to the internet. It's preparing them and issuing them for public distribution, or I guess you could sell them out on the internet. Now when this happens, the ISA server becomes the mediator between the two. And here's one of the advantages you get from using the ISA server to publish an internal server versus for just putting the server on the internet. When somebody from the internet comes into the ISA server and says, I want your web page, what's the ISA server do? Well, it doesn't just forward the request on to the internal web server. It actually acts as a proxy, a mediator between the two. We actually call this a reverse proxy because it's proxying, which normally goes out to the internet, in reverse. The ISA server tells the internet individual to hold on 1 second while it goes in and grabs the web content. It then comes back and returns it to somebody on the internet. So what this does is it actually allows the ISA server to never expose the IP address or any of the information about the real internal web server on the internal LAN. You could have 5 different web servers that you're load balancing between, and nobody would ever know the difference. It's all coming from the ISA server to them. Now, web server publishing supports 3 different protocols: HTTP, HTTPS, and FTP. So if your web server is running any one or all of those protocols, you can publish it using the web publishing feature set. Now, another feature that the ISA server provides is something called reverse caching, meaning that as the web page comes back through and goes out to the internet, you can have the ISA server cache it. So the next time, the ISA server doesn't even need to bother the internal web server. It's got the content cached for the internet. You gain all the benefits of caching in reverse. That's why they call it reverse caching. Now, this server publishing allows you to publish other servers. Well, we've been talking about web server publishing so far, but there's also server publishing to make email servers and other internal servers available to the internet. You can make just about anything available to the internet. However, you lose the benefit of getting that reverse caching because when you think about it, caching is something geared towards web content. This whole concept of publishing and web publishing takes me into this back-to-back environment. Now, in the previous nuggets, when we talked about firewalls and how the firewall feature set works, we were talking about this back-to-back environment being one of your potential designs that you could use. And if you watch that nugget, one of the things you'll hear me say is, well, we'll talk more about the back-to-back environment in a future nugget when we talk about publishing your internal resources. The reason why is because in the firewall nugget, we talked about some concepts like routing, IP routing, and packet filtering. This is a system that allows you to literally route traffic from the internet to the internal network and filter to keep the traffic out that you don't allow. This is what differentiates publishing from these two features. Publishing makes the ISA server a true proxy. It doesn't route between the two. It acts as a proxy. It intercepts the request and returns it from the internal host. The real request is never routed to the internal servers. Why is that good? Well, the reason why is because it increases your security. Nobody can ever reach these servers directly. Only the ISA server can. So that adds security to your network. The reason I bring it up now in this environment, a back-to-back environment, is because you will never use routing and packet filtering in this environment. Here's the idea. You will have 2 different real zones inside of your network. The first zone is between ISA Server 1 and ISA Server 2. I would consider this the DMZ, Demilitarized Zone. And what you would use is web publishing and server publishing for things like email to make these servers available out to the internet. And again, no one from the internet ever really gets here. Only the ISA server retrieves the content or the emails and sends them on to the internet. Now you see that we also have a second zone in this picture. It's behind the second ISA server. And this is not your DMZ. This is your internal LAN. Again, never, ever, ever using routing or packet filtering, because that is a little less secure since real traffic is being sent, but we can actually publish servers from the ISA 2 server to the DMZ. Now, why would you want to do that? Well, let's take, for example, this SQL server. SQL 2000 and Exchange 2000 are becoming more and more integrated, and you're going to see it even more so with some of the future versions of it. This email server, for whatever reason, may need to access this database. What you can do is you can publish the SQL server to the DMZ. What advantage do you get? Again, no traffic from the DMZ will ever reach the SQL server directly. Only the ISA server 2 can reach the SQL server directly. It takes an email server content and redirects it to the SQL server as if it was coming from ISA server 2. The reason that's good is, let's say worst case scenario happened, a living nightmare. Someone compromised the first ISA server. Firewall's down. Someone gets in and compromises the email server. Email server's down. Now they're trying to get into the internal network because they've pretty much taken down your DMZ. Now, first off, that's going to take a lot of work, and you'll probably realize what's happening before they can get to this level. But let's assume the worst. They get to the ISA server 2, and you have increased your security on the ISA server 2 to where this thing is a living fortress. And you've said that only the email server can access ISA server 2. And furthermore, the ISA server 2 is not to forward any other requests than maybe some basic queries from the email server. Those queries most likely will never compromise the SQL server. So this back-to-back environment is ultra secure, and the reason why is these features are never enabled. All of it is done using server publishing. So here are the guidelines for publishing in each one of the 3 firewall strategies that are out there. Now, just a reminder, we talked about these strategies in the firewall feature set. So if these are new to you, definitely check out the firewall because we dissect them one by one. If you're using the simple firewall strategy, to make a server available to the internet, you want to use just straight web publishing. And I suppose I should draw a key. The little circles are servers that you want to make available to the internet. So we will use web publishing, or I should say server publishing, to make this available, allowing the ISA server to act as a proxy for all those requests. In the back-to-back environment, we just talked about this one, publish the DMZ out to the internet, and then publish the internal servers, if necessary, into the DMZ. We use publishing on both of our ISA servers to accomplish that. The 3-home design is the only place that's a little bit different, because in this world we have our DMZ and our internal network coming off of the same ISA server. So we will actually use, for internet clients going to the DMZ, I'll put a D in there, IP routing and packet filtering. If we want to make a server on the internal LAN available to the DMZ, then we will use the publishing. Now you might be stuck in the quandary of, well, why can't we publish from the internal to the DMZ and then publish DMZ to the internet? It seems like it would work, right? Well, there's a few problems with that. That's the whole, I guess, dilemma of the 3-home system, is you are kind of scraping by getting 3 network cards inside of the same machine. The reason why is because, first off, you can only publish between an internal and an external network. So we can publish from the internal client network to the external addresses in here, or we could publish from the internal client network straight to the internet, which would somewhat defeat the purpose of a DMZ. With the DMZ, you use real IP addresses and you route between them. Because of that, you totally bypass the firewall service running inside of the ISA server because you're using true IP routing. So the next question comes and says, well, can we use private addresses in both the internal clients and the DMZ? Well, sure you could. It wouldn't be a true DMZ at that point by definition, but at the same time, at that point, you'd have 2 internal networks. You'd be able to publish from the DMZ to the internet, using the publishing wizard and server publishing, but you wouldn't be able to publish from the internal network to the DMZ because the ISA server will see both of these as being into the same local address table. I know it gets pretty complex and hairy when you really think about it, but overall, the idea is you publish from the internal LAN to the DMZ and then use IP routing between the internet and the DMZ with packet filtering. All right, well, let's get going. What do you need to prepare to publish servers to the internet? Well, the first thing that you need to resolve is a matter of DNS. DNS can get pretty ugly when you're starting to set up server publishing, and here's why. First off, you'll need to make sure that you have a DNS server somewhere on the internet configured to resolve a name to the external IP address of the interface. Now, this will be the real name of your web server that you're going to set up that public clients will access, something like www.cbtnuggets.com. That would be a real name that's resolved directly to the ISA server, and the ISA server will translate that in. That's not the big deal. People are used to that, and that's a normal part of configuring just a web server out on the internet. Now, where it gets difficult is when you're configuring the internal DNS for these clients. Here's the way it works. For SecureNAT clients, it's easy. SecureNAT will just go to whatever DNS server you want them to go to, an internal one, an external one, wherever, to resolve host names. And most of the time, you will have some sort of internal DNS server, and you'll say, okay, SecureNAT, go to this one. It will resolve all your DNS for you. I mean, you need DNS to run Active Directory, so why not? Now, the firewall client and the web proxy client, that's where it gets a little sticky. Here's why. The firewall client, I'll put an F here to remind us, the firewall client gets all of its DNS requests resolved through what's known as a firewall proxy in the ISA server. Whenever it needs to resolve a DNS name, it sends the DNS request to the ISA server. The ISA server becomes a proxy and goes out to that external DNS server and says, I need to resolve this. Comes back, gives it to the firewall client, and then the firewall client goes out and resolves the request and fulfills the request that the client had. Now, this works great for external resources. You have the ISA as a proxy, works dandy, but it pretty much fails at internal requests because a firewall client coming to this ISA server going to an external DNS server is not going to have the information about your internal network, and that's a good thing. So we're going to have to configure something to get around this for the firewall client, and we will do that in the live interface. We actually need to set up the local domain table. The web proxy clients present some challenges of its own as well. The web proxy client has to have its own configuration. Let me put a little WP here, because when it resolves it, it goes to the ISA server as well. However, it doesn't look at that local domain table. It doesn't look at the same settings as the firewall client does. So we're going to have to configure our own unique setup for the web proxy client. As a matter of fact, let's go do that now. First, let's focus in on the firewall clients, and we'll start setting them up for that local domain table. The configuration of this isn't hard at all. It's just something you'll have to remember if you do decide to publish internal resources. You need to expand the network configuration, and down here we have the local domain table. Anything that you put in here will be considered local by the ISA server. And when a firewall client requests something, they will try and resolve it using their own DNS server rather than forwarding it to the ISA server. So I just right-clicked on it, hit New, and hit LDT entry. And all we would do is type in whatever domains are considered local. And in this case, we might say I want to do star.local.com or whatever you would have as your local domain. And we've added that to the network. Now, this will replicate to the firewall clients, and they will all now try to resolve local using their own DNS configuration. Now, if you have web proxy clients on your network, you're going to go to this client configuration area down here. You're going to hit the web browser button, which pretty much lets you configure the settings for web proxy clients. And it first off says, do you want to configure the web browser during a firewall client setup? So when you're setting up a firewall client, it can configure the web browser as well. But we're interested right now in the direct access tag. This one allows you to specify right here, directly access these servers or domains. First off, notice that it has the checkbox checked by default to directly access computers specified in the local domain table. So if you've already gone into the local domain table for your firewall clients and set those up, you should be good to go. You won't have to do this individually. But you can also, if you just have web proxy clients, you can come in here and manually add the domains to this area. Either way, this allows your web proxy clients to bypass the, and let me go ahead and do that. It allows them to bypass the external DNS server for any locally specified domain that you've designed into that web browser configuration area. And that is how you lay down the DNS configuration for your publishing. Now, the next thing that you need to work on when you're starting to publish and getting ready to set up your servers is creating a destination set. I know, think back a little bit to setting up external access, and you think to the policy elements and you hit those destination sets. Now, this is a little change of logic, because usually the destination sets dictates what destinations our internal clients are able to reach out on the internet. But now reverse the logic a little bit. It's going to dictate what web servers or what servers the outside clients will be able to reach on our internal network. These will be required when you're starting to use the publishing wizard to set up servers published on the internal LAN. Now I'm going to hit new destination set, and let's go ahead and say this is our internal web server. Nice descriptive name for it. And I'll hit add in this list. Now, you are going to type into this field, the destination field, all of the names that your internal web server will respond to. I mean, one of the logical ones might be www.local.com. And by the way, local.com is just a domain I'm using for the name of our internal LAN. We'll add another one. Maybe our internal web server also responds to ftp.local.com. Okay? You can go ahead and type in all the names into this list. These are going to be the ones that your publishing wizard recognizes and directs to that internal web server. Now, you could get as specific as you want. For instance, let me remove these two out of here. And let's say we have an intranet server that happens to have a subdirectory on it that it uses for the public, meaning that I don't want public users out on the internet to reach the root web page of this. Instead, what I can do is say they can reach www.local.com, and then I will restrict them to using / maybe we created a virtual directory on that web server called internet. Hit OK, and now this is only going to make available to an outside user the virtual directory called internet on our internal web server. So we've actually applied a restriction just by saying they can only get to the subdirectory. Now we can use that internal web server for our intranet users, create some other virtual directory, or just use the root for them, and have a virtual directory for our internet users as well. You can go ahead and go through and create all the destinations you need for all the different internal servers. Don't worry, it's not going to suddenly make all of them available. It's going to let you select, as we get into the publishing wizard, what destination set you want to make available for each individual server. After you configure your destination sets for all the internal servers that you'd like to publish, you need to set up listeners. Now, I know we talked about listeners in the past in the previous nuggets, but let me do a little review for you. Listeners, first off, I'm going to go to the properties for the server, and we have listeners for, in this case, incoming web requests. A listener is pretty much port numbers that the ISA server will listen on the outgoing interface, meaning your internal interface, and the incoming interface. For instance, you can see outgoing web request is using the listener on 8080. What is that for? The web proxy service. On the incoming web requests, there is a default listener that is listening on port 80. Now, by default, it's going to dump all of that into the trash can, and I'll show you why that is when we look at the publishing rules. But what we're going to need to do is configure listeners if you want to go beyond this default. By default, the ISA server will use the same listener for all external IP addresses. That means if you have more than one external IP address bound to the interface, it will be listening on port 80 on all of them. If you'd like to configure it for each individual interface that you have in here, or each individual IP address, you can change it over to configure listeners individually. Click on Add, and it will allow you to choose the server followed by what external or internal IP address you would like to listen on. Now on this server, we only have one external address, so I would put that in here and configure this. But for now, I'm going to use the same listener configuration for all IP addresses. Now we looked at these authentication settings before, but let me highlight them again. This listener, again, by default is only on port 80, and down here we have our authentication options. We can authenticate people using a server certificate, and this is if we have a certificate authority set up and maybe we're issuing our own certificates, or we have a certificate that we've gotten from an external CA out on the internet, a certificate authority on the internet. We can actually authenticate them using that certificate. We can also choose these authentication options which are in the Internet Information Server as well. The main note that I want to point out to you, because we did talk about all of these in the firewall nugget, one thing I do want to point out to you is these authentication options are configured for authenticating to the ISA server itself. Here's a mental note to keep. When people access your ISA server, if you choose to have authentication enabled, this is authenticating just to the ISA server, not to the internal web server that you're publishing. So, in essence, you could have people authenticating twice to get to an internal server. So here's what I would recommend. I would recommend that you would have authentication enabled at the ISA server because that's your first wall of defense. Then go ahead and disable authentication on the internal server. Because they've already authenticated once, it's almost redundant to do it again. Unless you're in an ultra secure environment and you want to make sure authentication happens both times. That's just a tip. Overall, you can choose whatever authentication options you want. Now this is by default enabled for only port 80. If you want to enable SSL as well, you can check this Enable SSL Listener, and we're going to get a message when we do that. It says SSL requests will be accepted only if an appropriate server certificate is configured for each listener. That's saying you need to make sure that you have a certificate from either your internal CA or an external CA that you configure on that SSL. Now, that's the idea of configuring listeners, and as I mentioned, only the port 80 is enabled by default. So if you want anything beyond that, like FTP services, you'll have to start adding them individually for each IP address and each port number that you want. After we've configured the listener, the final step is to publish the server itself. And in this nugget, we're going to be doing a web server, not the other services. We'll talk about that in the upcoming nugget. Now, the way you publish a web server is by going to this publishing area. Hit the plus sign and you have web publishing rules and server publishing rules. Here's what I want you to see first off. There is a default rule. Its order is always last because any web publishing rules you add in front of this will be processed before. It kind of processes in a top-down list. It says, is this web server matching? No. Is this one matching? No. Is this one matching? Eventually, if none of your rules match, which there are none by default, you will have this last rule. Let me scroll over and show you what it does. Deny any request to all destinations. Remember I said when we were looking at the listeners just a moment ago that ISA server listens on port 80 by default? Some of you might have been thinking, wow, that's kind of insecure, isn't it? I mean, what if we don't have a web server? Well, not to fear. There's only one rule in here by default, and any request received on port 80 will hit this last publishing rule, which is deny the request. So let's go ahead and add one. I'm going to click on New Rule. Let's go ahead and say this is a rule for our internal web server. Click in that box. Hit enter, and it's going to say, do you want to apply this rule to all internal destinations or a destination set that you specify? Be careful with this. You don't want to select all destinations, or that's potentially opening any server that's internal to your network on port 80 to attack. We want to say, I want to have a specified destination set. Which one? The set that we just created a moment ago, specifying exactly what web server, and I believe that one even specifies what directory on that web server will be able to be accessed. I want to hit next. It says apply the rule to requests from any requests, specific computers, or specific users and groups. This is where you have the ability, if you'd like, to limit who can access that internal server. By choosing any request, that means any external person can access this. But look at this. I could specify a client address set and say, well, only this domain or this group of IP addresses could access it. Or if we're authenticating users, we can say only this user, this group membership can access this. That's a pretty powerful feature to limit access to your internal web server. I'll hit next. It says, how do you want to respond to those client requests? By default, like the default rule, it will deny the request. In this case, we want to make sure that we at least allow it to go somewhere. And we can choose an internal web server by name if you have a domain set up, or just type in the IP address. And in this case, let's say our internal web server is going to be at 192.168.1.68. That's its internal web address. Now here's a funny checkbox, and tell me if this doesn't sound confusing. Send the original host header to the publishing server instead of the actual one. What does that mean? Well, what happens when the ISIS server receives the request is it will convert the host header, meaning I'm trying to access www.local.com or whatever host header it's using, it will convert that to the internal name of your web server. For instance, we might have an internal name of webserver.local.com that we've specified. And by default, it will convert that. Well, if you're using host headers, which means that you have a single web server that's handling multiple websites, and the way it determines which website it's responding to is by looking at the actual host header. For instance, you might have www.header.com going to one website and www.2.header.com going to a different website. You can have it send the original host header if you are doing that, meaning the one that the external user requested. If you don't do that, it will always convert it to the internal name of the web server. So most of the time, I've seen people check this. Now look at this. We have the option, when we're bridging these over, to choose to bridge certain ports. For instance, when you receive the request on port 80, maybe you want to redirect it to port 85 on the internal network. This is known as port redirection. I've seen administrators do this for a few reasons. One is security, because maybe they don't like their internal web server responding to the default port. Maybe their internal users are trying to access that. But the main reason I've seen it used is maybe they have that internal web server handling multiple websites. And each website is hosted on a different port number, even though that internal web server only has a single IP address. Maybe it has a website on port 80, 81, 82, 83, 84, and 85. In this case, we're publishing a rule that will redirect it to port 85, which may be a specific website on your internal web server. SSL and FTP can also be redirected as well, if that's what you'd like to do. Hit Next, and it will give you your summary screen. Finish, and you see the rule added to the list. Internal web server is now order 1, which will be processed first. If that one doesn't match it, it will hit this last rule, which will deny the request. So if they're not hitting this specific website, it will deny the request. That's the idea of publishing a web server. As I was going back through and listening to all the recordings that I did showing you how to configure this and how to set this up, I thought to myself, this is begging for a checklist of what to do, because there's so many steps to do this. So let me give it to you. So if you're taking notes, you can jot it down. First off, set up your internal DNS zones. Let your clients know what zones are internal so that they don't go through the ISIS server to resolve those. That was the first step that we did in publishing the website, so our internal clients can access it as well as our external ones. The second thing, configure the destination set. Go through and make sure that you set up destination sets dictating exactly what you want to be able to reach on the internal network. Third, configure your listener ports. Now in this nugget, we went through and configured the listener ports for port 80 and even the SSL, and that allows you to listen and respond to certain port numbers on your external interface. Finally, complete the web publishing wizard. This allows you to tie all these pieces together and say, I want this destination set to be reached on this network, and point it exactly to what internal web server they will reach when they access the external interface. Finally, relax. You've got your first web server published to the network, and you're good to go. So in summary, in this first nugget on publishing, we discussed what is publishing, what does it mean to your network, and how do you make those internal web servers available to the outside. And finally, we went through and configured web publishing. Now I bet when you first saw these two bullets, you thought, wow, this is going to be a short nugget. Well, by the time it's said and done, there's a lot of considerations and a lot to do to make web publishing work. I hope this has been informative for you, and I'd like to thank you for viewing.